Hi everyone, myself Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today I want to discuss about my topic is Fourier series problems in 0, L. Previously we discussed with the Fourier series with minus L, L and minus 0, C, C plus 2L. Today I want to discuss about the topic on 0, L. Okay, for that, okay, 0, L. For that first problem, find a Fourier series with the period 3 to represent f of x is equal to x plus x square in 0, 3. Either 0, L or 0, 3. Here, they are particularly what they are asking 0, 3. 0, 3. But we have to compare that the interval with 0, L. For that 0, L, here what about the formula? F of x is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos n pi x by L plus bn sin n pi x by L. Okay, here what is the function? F of x is equal to x plus x square, and if you are comparing the interval with the 0, L, what about L value? That is 3. That is equal to, here we are comparing with 2L. That means 2L is equal to 3. L is equal to 3 by 2. L is equal to 3 by 2. Okay. And here L is equal to 3 by 2. For that, what about f of x? X plus x square is equal to a naught by 2 plus sigma n is equal to 1 to infinity an cos n by x by 3 by 2. L value 3 by 2. For that, we get 2 there plus dn into sine 2n by x by 3. Okay. This is the formula. Let us take that as the second equation. For that, I am finding a naught, an and bn values. A naught, an and bn values. Okay. For that, what about a naught? 1 by L into integral 0 to 2L f of x dx. What about L? 3 by 2. 3 by 2. Here I am substituting, and 2L means there 3. That is integral 0 to 3 x plus x square into dx. That means after the integration 2 by 3 into x square by 2 plus x cube by 3, after substituting the limits, then directly that value is equal to 9. Is it clear? Here the interval is 0, 3. Now I am comparing with the limits as 0, 2L only, not for 0, L. Why? Because it is in the form of 0, 2L. Okay. Then 2 by 3 into x square by 2 plus x cube by 3. After substituting and simplifying that, one subs are 2 by 3 into that is 3 square by 2 plus 3 cube by 3 minus 0, 0. That is 2 by 3 into, after the simplifying, this is 9 by 2 plus 1, 3, 3 cancel, this is 9. This is equal to 9. Okay, therefore a naught is equal to 9. And what about an? An formula 1 by L into integral 0 to 2L. 2L into f of x cos n by x by L dx. But L value 3 by 2. After substituting, the reciprocal is 2 by 3. Integral 0 to 3 x plus x square into cos 2n by x by 3 into dx. After substituting 3. Okay, again I am using the integration by parts. Integration by parts, for that, how we are using that integration by parts? 2 by 3 into, again, uv, or integration by parts are uv. For that, x plus x square as u, and cos 2n by x by L integration is sine 2n by x by 3 by 2n pi by 3, minus x plus x square differentiation is 1 plus 2x into sine, this integration is cos 2n pi x by 3 by 2n pi by 3 whole square, plus 1 plus 2x differentiation is 2 into that cos 2n pi x integration is sine 2n pi x by 3 by sine, here minus, and there also I will get minus, by 2n pi by 3 whole cube, and so on. Not so much. Then stop the procedure up to the constant term of the u. There the constant term as 2. Okay. This is the expansion for integral uv, and whatever the limits for that 0 to 3. Already we discussed if the sign term within the limits 0 comma l or 0 comma 2l or 0 comma pi or minus pi comma pi, whatever it is, sin n pi value 0 and sin 0 value 0. Then directly after substituting 0 comma 3 there, sin n pi 0 and sin 2 n pi 0, sin 0 also 0. Only I am substituting the limits is cosine term. Cosine term for that, after substituting the limits there, an is equal to 2 by 3 into 3 by 4n square pi square minus 4n square pi square. There 2 by 3 into here 54 into 9n square pi square. There cancel, that is 9 by n square pi square. Once observe, here substitute. There 2 by 3 into, once again I'll repeat this. Here this is 0 and this is 0, and cos 2n pi by 3, that cos 2n pi value 1, that is minus 1 plus 2 into 3, 1 by 4 pi square n square by 9, and the sign as 0 minus of again 1 plus 1 into cos 2n of 0, that is cos 0 value, cos 2n of 0 by 3 by 4 pi square n square by 9, cos 0 value 1. Okay, na? Here once observe, sign terms completely 0, and after substituting the limits in cosine, directly after the simplification we get directly 9 by n square pi square. And finally, what about bn? Bn formula 1 by L into integral 0 to 2L f of x into sin n pi x by L dx. Here 2 by L value 2, 3 by 2 after substituting this, and here 0 to 3 x plus x square into sin 2n pi x by 3 into dx. Again which is in the form of integral uv, and again for the same concept I am applying for bn, which is in the form of integral uv. Then okay, for that 1 by L into integral 0 to 2L 3 x plus x square into sine 2n pi x by 3 into dx. For that, okay, I am integrating. Here elements 3 by 2, there 2 by 3 x plus x square into sine 2n pi x by 3 integration minus cos 2n pi x by 3 by 2n pi by 3 minus x plus x square differentiation 1 plus 2x into cos and 2n by x by 3 differential integration is minus sine 2n by x by 3 by, okay, there 4n square by 9. Next continuation, plus 1 plus 2x integration is 2 into minus sin n by x integration plus minus cos n x, there minus into minus plus cos 2n pi x by 3 by, this is, okay, next continuation there, that is 8 into n cube by 27. Limits 0 to 3. Limits 0 to 3. Okay, after the integration this, substitute the limit points. From that, again sine terms are zeros, and substitute the limits only for the cosine terms. From that, after the simplification, directly we get minus 12 by n pi. Minus 12 by n pi. Here, how we are getting 12 by n pi? Here the limits 0 to 3. Substitute there. In place of x as 3, 3 by 3 cancel, cos 2n pi value 1, that is minus 1. 1 plus 3 square as 9, that is 2 by 3 into 3 plus 3 square, and there minus cos 2n pi value x 3 cancel, that is 1, minus sin as 0 plus 2 into cos 2n pi, this is 0, and there by 8n cube pi cube by 27. And similarly substitute the lower point zeros, 0 for that sine and cosine terms. There 0 plus 0 square first term is 0, and this is also sine 0 0 plus 2 into cos 2n pi of 0 by 8n cube pi cube by 27. Okay, from that after simplification directly we get minus 12 by n pi, minus 12 by n pi. Now we know that a naught, an and bn values. Substitute in the first equation, that is x plus x square is equal to 9 by 2 into 9 by 2 into 9 by pi square into sigma n is equal to 1 to infinity 1 by n square. What about an value? 9 by n square pi square into cos 2n pi x by 3 minus plus what about bn? Minus 12 by n pi into sin n pi 2n pi x by 3. Sigma n is equal to 1 to infinity. Now expand the sigma value there, or else directly this is also right answer. If you want to expand the sigma, then you have to expand n value starts from 1 to 3, or else okay, leave it. This is also correct answer for the function x plus x square within the image 0 comma 3. Next question, find the half range sine series of the function f of x is equal to 1 in 0 comma L limits. 0 comma L. Okay, here what about the function f of x is equal to 1 within the half range sine series? What about the sine series formula? Only we have to find bn value, that is sigma n is equal to 1 to infinity bn sin n pi x by L. Okay, here what about BL formula? Okay, 2 by L into integral 0 to L f of x into sin n pi x by L dx. Okay, here directly limit is L, that is 2 by L into integral 0 to L sin n pi x by 1. What about the function? 1 into sin n pi x by L dx. Here what about the function f of x is 1. Okay, for that I am substituting in place of x as 1 into sin n pi x by L into dx. That means directly integrate only for sin n pi x by L, that is integration of sin n pi x by L as minus cos n pi x by L, and the x coefficient is n pi by L, that is 2 by L into minus cos n pi x by L by n pi by L, limits 0 to L. 0 to L. Now substitute the limit points. Okay, that is 2 by n pi into LL cancel there, minus cos n pi x by L. Once observe here 2 by L into L take L by n pi minus cos n pi x by L, limits 0 to L. There 2 LL cancel, that is 2 by n pi into minus cos n pi x by L into 0 to L. Okay, after the integration over, after substituting the limits there, 2 by n pi into 2 by n pi into minus cos n pi x by L into limits 0 to L. That is, okay, here observe 2 by n pi into minus cos n pi x means L by L, minus into minus plus cos n pi of 0 by L. Here LL cancel, that is 2 by n pi into minus cos n pi plus cos of 0, that is cos 0, that is 2 by n pi into cos n pi value, that is cos n pi value minus 1 whole power n plus cos 0 value 1, that is 2 by n pi into, I'll take it as minus in powers, that is minus 1 into, I'll write it as minus 1 whole power n, cos 0 value 1, sorry, plus 1, that is 2 by n pi into, I'll write it as minus 1 whole power n plus 1 plus 1. Okay, this is Bn. This is the required value for the Bn, that is Bn is equal to 2 by n pi into minus 1 whole power n plus 1 plus 1. Okay, this is the Bn, and if you are taken in place of n as 0, before substituting the series, we are substituting directly there n is 0. If you have taken 0 minus 1 whole power 2 plus 1, that is minus 1 cube plus 1 minus 1 plus 1 0. If you have taken 4 plus 1, n as 4 minus 1 whole power 4 plus 1, that is minus 1 plus 1 0. Then if n is even, directly bn is equal to 0. If you have taken n as odd number, okay, if n is even, then bn directly 0. If n is odd, then what about bn? Once observe, 2 by n means 1, 3, 5 odd numbers. From that, 1 into pi minus 1 whole power 1 plus 1 plus 1, that is 2 by pi into minus 1 square means 1 plus 1, that is 4 by n pi. 4 by n pi. If n is 1 means there n is 1 now, that is 4 by pi. If n is 3, then in that case also it is positive, minus 1 3 plus 1, then directly we get, that is 4 by n pi. That means what we are observing, that if you have taken n as 0, directly bn is equal to 0. If you have taken n as odd numbers, then directly we get bn is equal to 4 by n pi. Therefore, what about the required series for f of x is equal to 1? That is sigma n is equal to 1 2 3 5 1 3 5 to infinity. Why I am taking? Why? Because if n is even number, in that case directly 0. Only we get the value if the odd numbers. For that case, 4 by n pi into bn sin n pi x by L. Okay, this is the required series. And if we have taken n as 1 means 4 by 1 pi into sin 1 pi x by L plus 4 by 3 pi into sin 3 pi x by L plus 4 by 5 pi into sin 5 pi x by L. But what about L value there? L value, that is 4 by pi into sin pi x by, what about L from the question? That is L is equal to, L is L only. Then directly sin pi x by L plus 4 by 3 pi into sin 3 pi x by L. Directly what they are asking, within the limit 0 comma L. No need to substitute L. L is L only. That is 4 by 5 pi into sin 5 pi x by L. Okay, this is the required series for the function 1 within the limits 0 comma L. Okay, what we discussed, now we have to discuss within the limits 0 comma L. 1 f of x is equal to 1 function, and similarly f of x as x plus x square in 0 comma 3 interval. Okay, this is the concept for the 0 comma L Fourier series. Therefore, these are the problems in the 0 comma L interval problems. Thank you for all. Okay, this is the concept of the Fourier series within the limits 0 comma L. Next class we will discuss some other topics in Fourier series. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.